All right, so I changed up the questions, the values in the question. I want everyone to multiply these two matrices and send me the answer on the chat. Good luck. All right, so we're going to be taking a 2 by 2 matrix. This one here is your 2 by, so let me get a different color here. This here is your 2 by 2 matrix, and you're going to be multiplying it by your 2 by 1 matrix, right? Remember, if the two inner values are the same, then it's okay to multiply it. So the two inner values are the same. And the two outer values, well, they tell you the size of your answer. So our answer will be a 2 by 1 matrix, which means there will be one answer here and one answer underneath, making it a total of only two answers. So let's get started. So when we're doing a scenario like this, right, you have to look at the smaller matrix, right? This here, and when you do that, you look at the underneath number, and he swings up to the top. I think last week I told you to pretend it's what Spider-Man or Batman or something like that, right? So the -2 swings up to the top. These two values now, the -5 and the -2, which are now on top, begin to walk across to the left-hand side of the screen. So the -5 is on top of the 3, and the -2 is on top of the -1. And the two yellow values, you photocopy them underneath as well. So you can just photocopy them underneath as well. And what do you do with each pair of numbers? You multiply them, right? So you're going to multiply each pair of numbers here. So I'm just going to put the multiply signs. And I think this is where the mistakes started to happen with the signs. -5 multiplied by 3 is -15, not positive 15. -2 multiplied by -1 is positive 2. -5 multiplied by 2 is -10, and -2 by 4 is -8. How much people have up to their correct? We're not finished, obviously, but how much people have up to their correct at least? And I'm talking about the signs as well, and not just like you have 15 and you think it's correct, it's -15. If you leave out a sign, like when something is supposed to be negative, and if you leave out that negative, you know we're close to being correct, it's considered completely wrong in maths, right? So we're supposed to get two answers, one on top and one underneath. To get the answer on top, we add the two answers that are on top. The two final answers, -15 plus 2, I guarantee you it's -13, not 17. -15 plus 2 is -13. And to get the answer underneath, well, you add the two final answers underneath, so you end up with -10 plus -8. But we know when a plus and a minus touch, you ultimately get a minus. So you end up with -10 minus 8, which is -18. This is the correct answer. Look for your mistakes, right? It's just simple addition and positive signs mistakes. I think most of you all understand the technique, but the signs is the problem. Right? Look for your mistakes, and for those who got it wrong, just confirm it that you saw your. So this is the one that has caused some headache in the exam, and we had time to do one last week. Now I changed up all the values, and don't think it's the same exact question. I did change up the values. So in a case like this, we have a 2 by 2 matrix multiplied by another 2 by 2 matrix. And when you do that, you get another 2 by 2 matrix. In other words, you get 4 answers. So last week I told you all to do a question like this. You take the first matrix and you multiply it by the first half of the second matrix. I have it here, look at it. It's the first matrix multiplied by the first half of the matrix. And when you do that, you get the first two answers, the yellow answers. And then you take back the first matrix, but then you multiply by the second half of the matrix, which I already laid out for you here. So it's basically two small questions inside this big question. So technically you're doing the same thing we did on the previous slide. We just end up doing it what? Twice. Okay? Good luck. Get your 4 answers for me, and then we're going to practice another one like this. So for the first one, I'm going to use a color here. Right. The -2 swings up to the top. And the same thing, the -3 and the -2, we photocopy it. Sorry, we put it on top of these two, and then we photocopy it underneath as well. Right? Multiply each pair of values, right? I always like to put my multiply sign here to remind myself that we're multiplying. Let me get a different color. -3 by -2 is +6. -1 by 2 is -2. -3 by -3 is +9. -2 by 5 is -10. To get the answer on top, we add the two values on top. 6 plus -2, a plus and a minus is a minus. So 6 minus 2 is 4. And then to get the underneath value, we add the two underneath values. A plus and a minus is a minus once again. So it's 9 minus 10, which is -1. So the first two answers is 4 and -1. I think some people had that wrong. Just check it back, right? But it's 4 and -1. I'm just double checking my working because I'm human as well. I can make mistakes sometimes, right? Right, but it seems that I'm correct. I double checked my work. Work out the underneath one, take the first matrix and multiply by the second half of the second matrix. So in this one here, the 4 swings up to the top. Now I'm going to have to clear some space here, right? So the working from the first one, I'm just going to have to clear this little area here, right? Because I need a little area here to show my working. So the 1 and the 4 walk across. So you have 1 here and the 4 here. And they also get photocopied underneath, the 1 and the 4. Multiply each pair. Let me just circle it and put my multiply sign, right? Let's see, get an orange here. 1 by -2 is -2. 4 by 1 is 4. 1 by -3 is -3. 4 by 5 is what? 20. To get the answer on top, we add the -2 and the 4. We'll get +2. When we add underneath, -3 plus 20, I think I'm going to get 17. So it's 2 and 17. And this is our final answer here. These 4 values. Look for your mistakes. Look for your mistakes. I'm sure it's just a simple sign error most of the times. Right. Good luck with this one. You're going to get what? 4 answers again. So I already split it up already. So we're going to multiply by the first half here, right? So the -5 swings up to the top. The -3 and the -5 go over there. They also get photocopied underneath. Multiply each pair. Right, let's go. -3 by -2 is +6. -5 by 3 is -15. Anything by 0 is 0. -5 by -1 is +5. So to get the 2, a lot of people are getting 21 on top, but I think something is wrong there, right? Because to get the final answer on top, we have to add the two values on top. 6 plus minus 15. A plus and a minus is a minus. So it's really 6 minus 15. And I think we get in minus 9 here. And 0 plus 5 is 5. So my first two answers is minus 9 and 5. Right? Look for your mistakes. Once again, it's just simple sign errors that people are making mistakes with. Work out the second half. I'll still give you a minute with the other half. Right, so I need to erase the little underneath piece here because I need the space for the working. Right, so I'm going to erase here. Right. Let's see who is right. The 0 swings up to the top. So is the 6 and the 0 walking to the left? 6, 0. And they get photocopied here. 6, 0. Let's multiply each pair. All right, get different color. Okay, this. 6 by minus 2 is minus 12. Anything by 0 is what? 0. 6 by 0 is 0. Minus 1 by 0 is 0. So to get the answer on top, we add the minus 12 and 0. We're going to get minus 12. Hey, and 0 plus 0 is 0. It's minus 12 and 0, not 6. Right? Check back your working. Check back your working. Right? 1 second, guys. Let's go. Right. All right, guys. So yeah, the internet was a little unstable. But the point is we moved on to the next question. And look at this question. What do you all see in this question that might trigger some stress in your head? Letters, right? You all notice is not just numbers. It have what? Letters. So here's what. Let me start you off on this question now. Everyone take down this. I'm circling this. This is the official question. And underneath, we're going to be doing the working. So everyone take down the thing that I just circled in red. And I want to kind of start you up on the question. And you could what? Complete it for me. Right? Don't get scared. It's not going to be hard. So once again, we're going to take the first matrix and multiply by the first half. I have it lined up here already. So don't let the letters get to you. We circle this letter as usual, that item as usual, and he swings up to the top as usual. Remember, minus y is the same thing as minus 1y. If you want to put in the 1, so to ease your mind, you could put it. So the minus 1y is Spider-Man. So the two values on top here now, as usual, nothing is changing. They're going to walk across to the left. So the minus 2 will end up on top of the x, and the minus 1y will end up on top of the 1. The minus 2 and the minus 1y get photocopied underneath as well. What do? We multiply each pair. Take down up to here. Right, I'm waiting on you guys. Take down up to there. You notice nothing has really changed there. Spider-Man swings up to the top. It just so happens Spider-Man is minus 1y, and everything else is the same so far. Same concept, correct? All right. Let's take our time and multiply each pair. Let's do that. So minus 2 multiplied by x is minus 2x. Minus 1y by 1, anything by 1 is itself. So minus 1y by 1 is minus 1y. minus 2 by minus 1 is positive 2. And minus, look at this one. I know some people might do this one wrong in their heads. Minus 1y by another y is minus 1y squared. Because when you multiply a y and a y, you get y squared. Take down up to there. Take down up to there. Now, we're supposed to get two answers, right? We're going to get two answers, well, four answers. Two answers here and two answers here. Right now, we're working on these two answers. To get the answer, the answer on top, we have to add the two values on top. Remember, a plus and a minus is a minus. Minus 2x minus 1y. Minus 2x minus 1y. You don't have to put the 1, because if you don't put the 1 is understood. It's really up to you. Tell me something. Is it possible to simplify this? Can we minus 2x and minus 1y? Can we squish them together to get one answer? The answer is no, and we should all know that by now. When you're adding and subtracting, the letter types must be exactly the same in order to squish them together to get one answer. So we have to leave it so. To get the underneath answer, 2 plus minus 1y squared, a plus and a minus is a minus. So we end up with 2 minus 1y squared. Once again, we cannot do anything. We cannot squish them together. So our first two answers are 2x minus 1y, and the other one is 2 minus 1y squared. I know it looks weird, but that's the answer. You think you can do the second half of the question now? Take the first matrix and multiply by the green values. And then you'll get these two answers. And you're finished after that point. Good luck. So I just need to erase the underneath part here because I just need some space here, right? All right, so Spider-Man swings up to the top, so minus 1 here. So the 2x and the minus 1 go here, and they also get photocopied underneath. Now we have to multiply each pair. I think some people forgot that you're multiplying each pair. Some people added each pair. You get different color, use green. 2x multiplied by another x is not 3x, it's 2x squared. 2x by another x by x is x squared. Minus 1 multiplied by 1 is minus 1. 2x multiplied by minus 1 is minus 2x. Sorry for the squish there. Minus 1 by y is minus 1y. You don't have to put the 1 because the 1 is understood if you wish, right? To get the answer on top, we add the two final answers on top. Once again, a plus and a minus is a minus. 2x squared, you end up with 2x squared minus 1, which cannot be simplified. And then minus 2x plus minus 1y. Plus and a minus is a minus. So you end up with minus 2x minus 1y, which also cannot be simplified. So this is our final answer for the entire question. That's it there. And a lot of people did get it correct. One or two people got it wrong, but I'm hoping that you saw your mistake at least, right? Give us some feedback if you, but for those who got it wrong at least, let me know if you saw your mistake. Let's go. I have a habit of lying, apparently. Okay. Let's go. All right, so now we're going to learn to do something called the determinant of a matrix. Don't let that big word scare you. It's going to be super easy. By the way, when it comes to finding this thing called the determinant of a matrix, it will always be a 2x2 matrix, the one with the 4 values in it. Anything else regarding determinant is not on the CXC syllabus. So I want everyone to take down the topic and take down your first question. We're going to find the determinant of matrix A. It's very common for people to name their matrices. Like when they get a dog, you just name it something, right? The same thing with a matrix. The name of this matrix is A, and the name of the next matrix is B. Nothing wrong with naming your matrices. Right. So in the exam, if they ask you to find the determinant of A, they can write it as a sentence. They could say, hey, find the determinant of A, and use and spell out the word determinant. Or they could say, find A and put two straight lines, right? Two straight lines mean determinant. So sometimes the examiner won't even use the word determinant. He will just use the symbol for determinant. And I'm going to give you the formula to find determinant, right? Could you, well, it shouldn't be too hard to imagine this because I'm going to draw it out. You all see two diagonals here, a green diagonal, and I'm going to draw a yellow dashed diagonal, right? The green diagonal is the one that starts from the upper left and goes down to the lower right, okay? The green one, the one that goes from the upper left to the lower right, the green one is the more important diagonal. I always want you to remember that. The green one is the more important diagonal. He actually has a name. He is called the leading diagonal. He has a special name. To find the determinant of a matrix, you always multiply the leading diagonal first, always. So I'm going to put it here. It will be 8 multiplied by -1. I'm going to simplify it after. And after you multiply the leading diagonal, you always must put what? A minus sign. I'm going to write it here. Must put. Always. So, and I'm going to be saying it till it's super annoying, right? So when you're finding the determinant of a matrix, you always multiply the leading diagonal first, and right after, no matter what, I don't care what happens, earthquake, tornado, it doesn't matter. Put what right after? A minus sign. And guess what you do after? Then you multiply the less important diagonal, the one who is not the leading diagonal. The next one is 3 multiplied by -4. Now, it doesn't matter if you put the -4 and then the 3. Remember, 1 by 2 is the same thing as 2 by 1. I want everyone, we're going to, and that's it. We just have to simplify this and we're good to go. So let's work it out and find the determinant. 8 multiplied by -1 is -8. We have to put a minus sign after, no matter what. That is this minus sign. I should probably use the same color so you don't get confused. And then we multiply 3 by -4 is -12. Right? 3 by -4 is -12. You all notice two minus signs end up touching. That will give you what? A positive. -8 plus 12 is +4. We are finished. Not all the times two minus signs will end up touching. It all depends on the kind of values they give you. Okay? So the determinant of A is +4. Take that down and try a practice question here now. Find the determinant of B for me. I'll use the symbol. Good luck. And look out for the signs, right? Signs could trick you. This. We always have to multiply the more important diagonal first. That's the upper left to the lower right. He's the more important one. So we have to multiply what first? 6 by 4. After we do that, remember, you must put what? A minus sign, no matter what. And then we multiply the less important diagonal. So -1 multiplied by -5. All right, let's work this out. 6 by 4 is 24. we must put a minus. Oh, that's on the same red. We must put a minus sign. And n minus 1 by minus 5 is normal positive 5, right? So you end up with 24 minus 5. The answer is 19 is the answer. Check it back. The answer is 19. Look for your mistakes. Look, yeah, I think some people mixed up the signs by mistake from their reactions and responses. Go. Oh, no, no. Okay, no. It have two questions here again. Find the determinant. But you notice it have some letters in it. Don't let the letters get to you. If it's possible to simplify your final answer, simplify it. If it's not possible, but then you have to leave it like that. Good luck. This here is the more important diagonal, right? So we multiply that first, use my little symbol for determinant there. So it's 2a multiplied by 1, must put a minus sign after. And then you multiply the less important one. Minus 2 multiplied by minus b. 2a by 1 is 2a, minus 2 by minus 2 by minus, well, 2 by b is 2b, and a minus is a positive. So you can leave it out there, right? Can you simplify this? No, because one has a and one has b. That's the final answer. Somebody had 2a plus 2b here. Remember, minus 2, let me do it. Some people are getting a little confused here. So if it's minus 2 by minus b, 2 by b is 2b, fine. A minus and a minus is a plus. Now, I didn't put in the plus because I know when a plus touches the minus, I'm ultimately going to get the minus. So the answer is 2a minus 2b. Right, so look for your mistakes there. Take a 20 seconds for the next one. Some of you all say you just want a little bit more time for the second one. See the next one. Let's find the determinant of b. Use my little symbol there. Multiply the more important diagonal first. 5 multiplied by minus 2p. You must put a minus sign. And then it's minus 5 multiplied by minus p. All right. 5 multiplied by minus 2p is minus 10p. Must put that minus sign. 5 by p is 5p. And when you multiply 2 minus, you get positive, right? Now, a positive and a negative will give you a negative, right? So you end up with minus 10p minus 5p. That is minus 15p. Right? Right, so look for your mistakes on this one, right? The first one, remember we multiply the more important diagonal first, and we just minus in the less important diagonal after, right? Right, so take down this topic, just take down the topic, the inverse of a matrix. So I don't write down the two questions, only write down the blue question. Now, a lot of people don't know what the inverse of a matrix is, right? Let me put it in a way that you can understand it. Everything has an opposite, right? The opposite of white is what? Black. The opposite of hot is cold. In maths, what's the opposite of 2? The opposite of 2 is a half. You get, and I know that seems weird. You might think it's minus 2, but it's really a half, right? You could think of an inverse as the opposite of something, the inverse of something. Like, so what we're going to do is find the opposite of matrix P. So whenever I ask you to find the inverse of a matrix, think of it as this. You're trying to find the opposite of the matrix. Now, finding the opposite of the matrix, it's not as simple as just going to each number and making each number the opposite. It doesn't work like that in matrix land. To find the inverse of a matrix, I won't say that there is a formula, but it's more of a technique rather than a formula, in my opinion. Also, the symbol for inverse, right, is this. Like if the name of the matrix is P, the examiner will ask you to find P minus 1. You don't need the bracket, sorry. P with a little minus 1 over it, that means the inverse of P, the opposite of P. So the first step in finding the inverse of a matrix, the first step is to find the determinant. You think everyone could find the determinant of matrix P for me? That is why I was showing you how to find the determinant just now, no? Because it is use the determinant to find the inverse. So I was kind of setting the path to this question. Find the inverse of P and send the answer on the chat. It should be easy by now. To find the determinant of P, remember we have to multiply the more important diagonal first, right? So we have minus 4 multiplied by 2. I think most people have that. You must put the minus sign. And then you multiply the less important diagonal. 5 multiplied by minus 3. Minus 4 by 2 is minus 8. You have a minus sign here. 5 by minus 3 is minus 15. So we end up with 2 minus signs touching here, right? So you end up with minus 8 plus 15. I think that's 7. Look for your mistakes, guys. It's not minus 23 or 23. It's 7. Now, just want to remind you, even though it may be obvious, that is not the inverse. Finding the determinant is the first step of the inverse. To find the inverse, here's what you do, right? Remember the symbol for inverse. If the name of your matrix is P, it's P minus 1. That's the symbol for inverse. Whatever you get for the determinant, no matter what you get, whatever you get for the inverse, always put it underneath a 1, right? So I'll put in a little thing here. Always. That 1 will always be there. So if we got, they're saying, if we got 8 for our determinant, just throw it underneath a 1. I want everyone to do that, and then I want you to write a big pair of brackets here. Now, don't worry, you need more than one examples for this technique to stick. So whatever you get for the determinant, just throw it underneath a 1. Don't even think about it. Throw it underneath a 1. Right. You see, something is going to go inside this green brackets. You see the more important diagonal. Remember, the more important diagonal was the minus 4 and 2. You are going to switch the positions of those two values. So the minus 4 and 2, the 2 going to jump where the minus 4 is, and the minus 4 is going to jump where the 2 is. The 2 is going to go here, and the minus 4 is going to go here. The leading diagonal switch their positions. That's part of the technique. Do that for me, right? Right. Now, what about the less important diagonal? The less important diagonal, that is these two values that are circling in red. They don't move. Listen to what I say. Don't switch them. Look at each of them and just make each one the opposite. I put an OPP for opposite. Just make it the opposite. So let's look at the 5. What's the opposite of positive 5? Minus 5. And what's the opposite of minus 3? Positive 3. That's it. You're done. That's the inverse. We're completely finished with the question. Let me just repeat that. Whatever you get for the determinant, always throw it underneath a 1. Then put a big pair of brackets. The leading diagonal, you switch their positions of the values. The less important diagonal, you don't move the values. You just look at each value and make it the opposite. So the opposite of positive 5 was minus 5. The opposite of minus 3 is positive 3. And we are finished. I want you all to try to find the inverse of the second question. Find M inverse for me. M inverse. Let's find the determinant of M first. I'll do some of the work in here. So we multiply the more important diagonal first. So to find M determinant is 1 multiplied by minus 7. You must put a minus sign. And then you multiply the less important diagonal. Minus 2 by minus 1. 1 by minus 7 is minus 7. Minus 2 by 1 is 2. Well, 2 minus makes a positive. So you end up with minus 7 minus 2. I'm getting minus 9. So we all agree that the determinant is minus 9. Not positive 9, minus 9. Now, if we're not finished, remember, that's just the determinant. To find the inverse of M, so I'll put M with a minus 1 here. Whatever we get for the determinant, I told you no matter what, throw it underneath a 1, right? So we throw the minus 1 underneath a 1. The more important diagonal, what do? We switch the positions. Minus 7 jumps here, 1 jumps there. We switch the positions of the more important. And then the less important diagonal, we do not move them. We just watch each one and we make them the opposite. What's the opposite of minus 2? Positive 2. What's the opposite of minus 1? Positive 1. That's the end of the question. That's the inverse of M. Right? So we did 2 examples there. Don't worry, more is going to come up in a little while. Right? So just a quick question. Someone asked when we might be starting past papers. I could see, I mean, I will do 1 or 2 past papers in between, like when I finish a topic. I will do past paper style questions on that topic, but mainly past papers will start probably in April. But like I could see it happening around there, right? All right. So we have plenty of work to cover still. Let's go. Right, we have 2 more questions on the screen. Find the inverse of both matrices. Right. Let's find the determinant first. That's always the first step. So multiply the more important diagonal first. Right. I'm working it out a little bit faster. I think I could probably skip these steps now where I refresh your memory on all the signs. Minus 5 minus positive 12. I'm getting minus 17 for the determinant, right? Look at the working. You should be able to spot your mistake. It's minus 17. But we're not finished. Whatever we get for the determinant, throw it underneath a 1. So I'm going to throw that minus 17 underneath a 1. The more important diagonal, you switch positions. So 5 jumps here, minus 1 jumps there. The less important diagonal, you look at each value. You don't move them. You just make each one the opposite. So the opposite of minus 2 is positive 2. The opposite of minus 6 is positive 6. How much people got that without my help? Got everything correct without my help. Right? If you didn't, look for your mistakes. Look for clear the screen. Right? Let's find the determinant here of P. 6 by 0, well, that's the more important diagonal. 6 by 0 minus 2 by minus 1. So, oh, I think some people made a mistake here. Anything multiplied by 0 is 0 and not 6, right? I got minus 2 for the determinant. So I'm hoping you all got that as well. Minus 2. So to find the inverse of P, whatever we get for the determinant, which is minus 2, we always throw it under 1. The leading diagonal, we switch positions. It has nothing to do with switching signs. We're just switching positions, right? 0, 6. And the other diagonal, we don't physically move anything. We just make each value the opposite. Opposite of minus 1, minus 2 is positive 2. Opposite of minus 1 is positive 1. Right, so a few people asked how we got minus 2 here. I'm not too sure. I have all the work in here. I'm not too sure how to explain it back. We have just check it back now. I'm not too sure how to better explain how I got minus 2 here. Every single piece of working is on the screen there. Right, so check it back and just clarify. Sometimes you're just tired now. You're watching and you're tired. Just take a few deep breaths, watch it back, and see if it makes sense. All right, so sometimes the examiner will give you a special type of matrix, right? There's a special type of matrix called a singular matrix. A singular matrix is a special matrix in maths. It's a matrix where the determinant is always 0. I guess it's not too special. It's just for example, I want you all to find the determinant of this blue matrix, not the inverse. I just ask you to find the determinant. That's the easy type of question. Find the determinant of matrix K, and then find the determinant of matrix P, and let me know if both matrices are singular matrices. In other words, if you work out the determinant, you're supposed to get exactly 0. But see it for yourself. Just don't say, all right, it has to be determinant and singular, right? Work it out and see for yourself. Right, so multiply these two first. So it's minus 1 multiplied by 10. Must put a minus sign after. Then the 2 by the minus 5. That's the less important one. Let's see if it's actually. Minus 1 by 10 is minus 10. We have a minus sign here. 2 by minus 5 is minus 10. Right, 2 minus make a positive. So minus 10 plus 10 is 0. So the first one is indeed a singular matrix. Okay. Is the next one a singular matrix? And I put a fraction there just to kind of freak you out, but I hope it didn't freak you out too much, right? Don't let fractions get to you. It's a regular boring number. To find the determinant, multiply the more important matrix first. A half multiplied by 8. Must put a minus sign after. And then -1 multiplied by -4. A half multiplied by 8. A half of 8 is 4. Put your minus sign. -1 by -4 is +4. Yeah, you're going to get 0. Both of them are singular matrices, right? Don't let fractions get to you, right? So take a 20 seconds, take this down, and I think I have one more question on singular matrices. Right? Right, so this is how the question might come in the exam with regard to singular matrices. It's going to be a solve for X question. The question will come like this. Solve for X if matrix K is singular, because it's the blue one is matrix K. So everyone take down the question. It's a solve for X question, which means we're going to have to try to get X on one side and, well, everyone else on the other side. But I want to do the blue one for you, and then you could try the pink one as practice. Right. So the examiner came out right and said, K is a singular matrix, right? He's not asking you if it is a singular matrix. He's telling you it's a singular matrix. So what do we know about singular matrices? Well, the determinant is always equal to 0. So let's find an expression for the determinant. We're not going to get a nice number because it has the letter X. We're going to get what? An expression. So let's find the determinant. -1 multiplied by X. Must put a minus sign. And then 7 multiplied by -3. Let's simplify this. -1 by X is -1X. Well, 7 by -3 is I just put it here, -21. And who waited on the outside? A minus sign. So 2 minus will give you what? A positive. Is it possible to squish these two together? No, because one has an X and the other has no X. But this is the expression for the determinant. That's as simple as we can get it right now. But the examiner is asking us to solve for X. Because we know it's a singular matrix, we are allowed to put it equal to 0, because the expression for the determinant is supposed to be equal to 0. So let's solve for X quickly. We throw across +21, we're going to get what? -21. The -1 is a multiply. When you throw across a multiply, you get a divide. The answer is +21. So the moral of the story is this. If the examiner tells you the matrix is singular, you find the expression for the determinant, and you have no choice but to put it equal to 0. By doing that, you will form an equation. Solve for X from that point. Try the second question for me. Okay. Solve for X, knowing that it is a different answers, unfortunately, but let's see. Let's find the determinant. So we're saying 3 multiplied by 5, must put a minus sign, and then it's -2 multiplied by -4x. 3 by 5 is 15. Let's see, 2 by 4x is 8x, and 2 minus signs make a positive. So even if you decide to put a positive here, a positive and a negative is a negative. So you end up with 15 minus 8x. That's the expression I got for the determinant. Now we know it is what? Singular. The examiner didn't make that a mystery or anything. So we put the expression equal to 0 because all singular matrices, the determinant has a value of 0. Let's solve for x. Throw across positive 15, we get what? Minus 15. So we get minus x is equal to minus 15. The minus 8 is a multiply. Throw it across, you get a divide. Running out, that's I could probably write it down here, right? Let's see. 8 divide. Now, I know you're all going to round off differently or put it as a fraction. Remember, I always advise you go to 2 decimal places. 15 divided by 8. Well, I'm going to put the full answer, 1.875, right? You could round it. I'm not going to fight about the decimal places at this point in time, okay? So if you want to put 1.88, 1.875, 1.9, I'm not going to fight about it tonight, but anything around that will be considered correct tonight, right? Look for your mistakes. Remember, the solving for x, we covered this a long time ago, right? So I'm not going to be able to review that now, obviously, right? Right. So for those who missed but I think if everybody who was here last time, I showed you where to find all the missed videos and whatnot from last time. All right. So coming close to the end of